Yay! Hello, good morning. My name is Barry Dorrans. I'm Microsoft's .NET security person. The slides and everything else will go on my website in about 50 minutes after everything has been completed. So don't bother taking pictures, don't bother taking notes. And the speaker notes in the slides will have links to the original white papers and vulnerability reports of the issues I'm going to cover today. So I'm going to go through hopefully, seven cases of things that have caused Patch Tuesday events. And then I'm going to talk around how you need to improve your cryptography in your application. Now, these are not just .NET vulnerabilities. An awful lot of these apply to other languages, and I will give examples of how they apply as we go along. So my role is basically to try and get everyone in the .NET organization to code securely. And then I'm the person that gets emails and telephone calls for Patch Tuesday if I have not been successful. Which means I have had one phone call when I was on honeymoon and one phone call on Valentine's Day, which both of these made my wife extremely happy, but she's very understanding. So when a vulnerability gets reported, someone will email secure@microsoft.com, and MSRC, who are the people that manage all of this, will open a case and put it into Dynamics, and then I have to use Dynamics, and then I get an email. And I try from the report to reproduce the bug. And usually I can do this. Sometimes I have to ask MSRC for help because I'm not as clever as I would like to think I am. And then we have to reproduce it against all supported operating systems and software configurations. Microsoft has an awful lot of those. We have an awful lot of operating systems that are still in support, and each of those operating systems has 40 to 50 different languages. And so as you can imagine, I have an awful lot of VMs. We then develop the fix, and that usually takes 1 to 2 days. And then we test it against all the supported operating systems and software configurations, and that takes a month. Maybe 6 weeks. I'm sure some of you are going to be surprised about the fact that I say we test these things, because I've seen what happens when Patch Tuesday goes wrong. But I assure you we test them. Then the fix gets deployed internally at the same time as I'm writing the text for Patch Tuesday. And then on Patch Tuesday at 10 a.m. in the morning, everyone is in the office. We press magic buttons. And the bulletins appear for .NET Core. It's on GitHub, and the fix is released. Hopefully. So I'm going to go through a few things. I'm going to go through a HashDOS, padding oracle, remote code execution, more remote code execution, another denial of service, a nation-state attack, and then what happens when you trust user input when you shouldn't. So a hashing denial of service is a denial of service that comes from the way that you use hash tables. Hash tables are used throughout ASP.NET and a lot of web frameworks for putting things like form inputs into, or a query string, so that the developer can pull these things out happily. Now, the way this works is basically, if I explain this with cats, which is an explanation that I took off someone else on the internet, and they are credited in the notes. If you have a bunch of cats and you go away on holiday, you want your cat to go into a cat boarding house, so they are safely looked after. So you take your cat to the cat boarding house, and the cat boarding house has to file your cat away so you can get the right cat back when you come back. I assume that's important to cat people. I don't know. I'm a dog person. But it wouldn't be important to me. I'm not particularly happy with cats. But whatever. So if I take my cat, and my cat is named Alphonse, we're going to use a simple hashing algorithm where we're going to take the first letter of the cat's name, and that will be the hash for that cat. And I put Alphonse in the A room. And then I come along with a second cat, and my second cat is called Bartholomew, and Bartholomew is hashed to a B, and it goes to the B room. And then when I come back again, I say I would like to pick up my cats, and they ask their names, and they go into the A room and bring back Alphonse, and they go into the B room and bring back Bartholomew. Hopefully there are not two cats of the same name. And then an attacker comes along who wants to knock this cat boarding house off the cat boarding house internet. And so he turns up with a bag full of 1.5 million cats and says they are all called Alan. So they have the same hash code of A, and the per cat boarding house person takes each cat and he puts them into the A room one by one. And the A room, it's getting slower and slower with each cat because they share the same hash. And it's getting more and more difficult to push them in there. And then you come back and say, I would like to pick up Alan. And so the per cat boarding house person goes into the A room and he picks up a cat called Alan and he brings it back and he says, is this Alan? And you go, no. So he goes back and he picks up a second Alan. And you go, no. And he could do this, you can do this all the way down until the last Alan that you pick of the 1.5 million cats called Alan who are in a tiny, tiny room and are really unhappy and have sharp claws, because that's what cats do. It takes an awful long time, and you eventually say, okay, that's definitely the right Alan. So that is your denial of service, because what used to be a quick operation, just putting Alphonse into a room, is now a very complicated operation because there are 1.5 million insertions to be put into the same space. And retrieving from that takes even longer. Thus, we have a denial of service. This was originally exploited against PHP, Java, Python, and JavaScript. So if you're writing in any of those, you have a problem. And then someone decided to have fun and to try and write it for ASP.NET, which was great. So as you can see, there are other CVEs against other languages and platforms. It's not just a .NET problem, it's a problem industry-wide. And it's generally been fixed in a couple of ways. You've changed your hashing algorithm so it's not predicted. So an attacker cannot craft form values and form names, form input names, to clash. Or you limit the dictionary size. So you don't have a dictionary that expands out to 1.5 million cats. You have a dictionary that expands out to 200 cats, at which point it's still reasonably quick. By limiting, of course, you need to think about the number of inputs that you're actually legitimately going to have. In .NET, we did both. We had a quick fix where we just limited the number of form inputs that we would accept. And then we switched to a different hashing algorithm where it is not predictable. We seed it with a random value that starts with every process. And then there's hopefully no way that an attacker can get access to that random value. And so the hashes are not predictable. So I have demos, because like any good person, we like demos. My demo skills are not good. You can see that I write really, really pretty UIs. So the first thing we are doing here is we are going to assert 1 million values with a good hashing, a good hash algorithm into a hash table. And then I have a bad hash algorithm, which I've just written, so it's exactly the same no matter what the input is. And if I leave this running, it won't be done by the time I'm done. In fact, it might not be done by lunchtime, because everything is clashing and the per computer is getting overwrought and overexcited. So I will stop that. So, like I say, there are a number of ways to fix this. We can limit the size of dictionaries. You should also look where you are taking user input, form fields, query strings, any sort of user input, and using that as a key in your software that then gets fed into a hash table, and try and avoid that. Or you change your hash code algorithm so it's stronger and we have this implementation of a session key. That's one. Then we have padding Oracle attacks, which have got nothing to do with the database, although Oracle has actually exposed a few. A padding Oracle attack is where there's an information disclosure that can lead to all sorts of fun things. Oracle coming from the Greek concept of the prophetess at Delphi, who just give cryptic answers to everything that people took as prophecy. So in ASP.NET, we had an endpoint exposed which validated whether a string was encrypted correctly. And this string was a file path that we would serve up from the server as a JavaScript resource. But if you fed it the wrong encrypted string, it would error. And it would error in a way that was detectable. It would, you would either get an exception as opposed to success. So the attacker could use this yes or no to build a properly encrypted string without actually knowing the key. And when they did that, they built a properly encrypted encrypted string for web.config. And if any of you are ASP.NET developers, you know that web.config contains a bunch of stuff like your database connection strings and the username and password for that database. It also contained the encryption keys for membership cookies. So I could now craft a membership cookie using the exposed encryption key and log in as anyone I liked, which is obviously not what you want to do. So the way it works is there's an awful lot of mathematics behind it. I am not going to pretend that I can explain it that much. But when you encrypt things using a block cipher, it splits things up into little blocks, hence being a block cipher. And so you have the first block, and you encrypt that first block, and the result of that encryption feeds into the second block, and the result of the encryption of the second block feeds into the third block, and so on and so forth. But all the blocks have to be the same size. So the last block is often not the right size, so it gets padded with values. And so when the padding is wrong, the language throws an exception, and that exception is detectable due to timing. And once you have that detectable exception, you can start working backwards. You tweak the last bit in a value, and it errors or it doesn't, and you know it might be correct. And you work backwards like that until you have an encrypted string without having to know what the encryption key was, because you could do it by detecting errors. These are everywhere. On big Citrix devices that were used for load balancing and for a big IP, which is another load balancer. OpenSSL has had a number of these. OpenSSL has had a number of everything. But in this case, they were probably one of the first, because that's what the original attack was against. Java's had them. Erlang seems to be the most recent one that I find. So again, this is not limited to .NET. So the way you can fix it is you don't expose a padding oracle. You look at all the cryptographic operations that you do where that result might be sent back to the user, and you don't return detailed errors. You don't return, yes, this is good, or yes, this is bad. And then we have SharePoint. How many of you are SharePoint developers? No one. You lucky people. How many of you are SharePoint users? Yeah, okay, I'm sorry. SharePoint is based on ASP.NET, and SharePoint is the bane of my life because they do things to ASP.NET that it was never, ever meant to do. So errors in SharePoint generally end up with me because I then have to fix the underlying issue. So SharePoint has, or did have, a remote code execution via serialization, and I'm going to talk a bunch about serialization. How many of you are old school ASP.NET developers that used web forms? There are a few in the room. Okay, so web forms had this wonderful hidden field called ViewState. And ViewState was a binary representation of an object graph. And contained in that binary representation of the object graph was a list of the object types and then their values. And so when ASP.NET encountered it, it would look at the object type, it would create it, and then it would feed the values into it. And there are certain classes in .NET that should never have been marked serializable. We got rid of a bunch of them in .NET Core, and then everyone complained, and we had to bring them back for back compatibility, which is the bane of my life. But by allowing you to just blindly create objects that are in the framework, it can expose you to vulnerabilities. There are certain objects where you can introduce remote code execution. And we had protected against this by default because ViewState was signed with a cryptographic key. If it's not signed, you could put everything into ViewState and things would go haywire. And like I say, ViewState was implicitly trusted, and it would just create everything in the object tree. SharePoint did not like this signing mechanism because it made it really hard to scale things out in a web form, because you had to match the signing key on every single machine, and that was hard to do. So they turned it off, thus exposing the remote code execution. And the one that was demoed by James Forshaw, who works at Google, was using the temp file collection class. So one of these things that should not be serializable. The temp file collection class is quite handy. It allows you to say, give me a temporary file name that is unique and that I can use to do whatever I want with. And it stores these in an array. And when the class is garbage collected, it goes through that array and it deletes all the temp files. And the list itself is settable in code. So you could put file names in this object that are rather important, web.config being the obvious one, because if there's an ASP.NET website and web.config goes away, the site doesn't start. So James put web.config into this class, he serialized it, and he fed it into SharePoint. And SharePoint took it, the classes got instantiated, and then eventually when the garbage collection came along, SharePoint deleted its web.config and took itself offline. Which is a good thing, because for any of you that have used SharePoint, SharePoint being offline may well be considered a good thing. Unfortunately, SharePoint did not find it as funny as I do. So if I go back to my little demos, I have a ViewState demo here. It's a startup project. I'm going to click Start. Now here I have a web.config that I have created. And here is a binary serialized temporary file collection that I am going to read in and I am going to deserialize blindly. So if I go over here and hit enter, I force the garbage collection because no one ever wants to wait for that because it can take like minutes or hours. But my web.config has been deleted. Yeah, no more SharePoint. Yes. Because we blindly deserialized an object. I just want to make it clear, SharePoint turned the protections against this stuff off. And there are other instances of this. Binary formatter is perfect for this sort of attack. Exchange used it for serializing voicemail for transcription. So if you had a login to an Exchange server, you could send the same sort of binary formatted information to the voicemail endpoint and sort of take down Exchange. Docker was even better at this. Considering that Docker is new, they should have known better. They had a bunch of commands that are sent over named pipes to their system service. So they have a service that was running elevated. They had a bunch of named pipes which were not access controlled in any way. The commands were encapsulated in binary formatter. So you could sit there as a low privilege user on a Docker machine, send commands via binary formatter to Docker, and Docker would execute them as system, which was fun. So I have a slightly more fun demo for this one. If I switch to serialization exploit, so what I'm going to do here is I'm reading in the file. I'm just going to call deserialize on it, and lo and behold, horrible things will happen. So if I hit enter, PowerShell starts up. That's not in my code anywhere. PowerShell has gone out to the web and pulled something down, something horrific, and then it starts AE, which never switches to correctly. And the most horrific thing I could think of was, what on earth are you people doing pickling various parts of the pig and eating them that should not be eaten? So that is not the sort of thing I want to see. Okay, it may be the sort of thing that you do like. I mean, I'm from Ireland. We still eat blood sausage. I'm okay with that. But pickled feet? No, that's wrong. So binary formatters are a horrible, horrible thing. And it's not just .NET. The big Apache vulnerabilities that exposed a bunch of information from one of the US's credit agencies that took my name and address, date of birth, my credit history, my social security number, and exposed it on the web, were binary serialization bugs. Drupal has had them, WebLogic has had them, Tomcat has logged them, PHP have had a number of them. It's not just .NET. So you fix this in a different way. You remember I said that we had signed view state by default. When you are round-tripping state to a user-controlled space, you sign it. And you sign it with a cryptographically secure signature, an HMAC. And then you don't publish your signing key. Because GitHub is great for this, looking for things like signing keys for serializers in config. And you shouldn't be using any serialization formatter anymore that actually allows this type of unconstrained deserialization. You use ones where you can say to the serializer, I am expecting this object and this object only. And if you encounter anything else, throw an error. So there have been a bunch of Black Hat presentations about this. These were the formatters that were called out. There was a bunch of Java ones. There was a bunch of .NET ones. There are others, as you can imagine, the Apache one being the best example that I can give you of how horrendously wrong this can go. How many of you use regular expressions to validate user data? You're horrible people, and let me explain to you why. Aside from the fact that regular expressions are really hard to read and understand, who said no? They are. You're wrong. They have this the concept of backtracking. And backtracking regular expressions mean that you can send it backwards through the validator, through the original object that you're trying to validate, and go backwards and forwards and backwards and forwards and backwards and forwards. .NET is stupid in this regard. .NET never puts a timeout on a regular expression by default. So when you have one of these things, they can run for a very, very long time, and you're going to have to go through all your code and add timeouts. So would the person that said that no regular expressions were easy to understand like to explain to me this one? Here we go. This is a regular expression for validating email addresses. Who was it that said no? It's still going. Oh, there we go. It's at the end. This regular expression actually comes from jQuery. And people had asked for features in the .NET validation stuff for validating things like email addresses. So someone thought it was a clever idea just to use the one that was used in jQuery and give appropriate credit. It wasn't. You see, jQuery doesn't really have to worry about denial of service attacks, because you're denial of service attacking your own browser. Who cares? You knock yourself offline. I don't. You do this in a server, on the other hand, and we have bigger problems. So here I'm going to test it against a good value, and then I'm going to test it against a bad value. And because I haven't set a timeout, this is going to go on for a very, very long time. And then there are only a limited number of threads you have on any web server. So you just send a few of these requests, and you bring the web server down. It's another of denial of service attack. It eventually clears itself up because they will eventually complete. But eventually could be in a day, and no one wants to have their web server down for a day. They're everywhere. Here is a small selection. Perl, you know, the language based on regular expressions, has had this. Flash has had it, which is always good. NPM, Express.js, and others. I told you not all of this was going to be .NET related. So the way that you fix this is obviously to abandon regular expressions because you're a horrible person and your colleagues don't like you because they can't understand the regular expressions that you wrote. But that's probably not a good idea if you want to stay in your job, because understanding regular expressions gives you job security. So we look, and certainly in .NET and in other languages, we make sure that we are setting timeouts on regular expressions. If you're worried about this from a .NET point of view, there is a quick fix. You can set a global timeout using that option in .NET at the start of your program. And then we have abusing WSDL. How many of you are still using SOAP? Oh, do you all work for governments or banks? So I know the world has moved on, but SOAP actually gives us a bunch of fun security features and encryption features. And so, you know, REST is not there yet. And SOAP has this concept of metadata called WSDL that gets used to generate proxy objects that make it easier for you to call your SOAP classes and your SOAP services. REST, of course, is now doing exactly the same thing and making the same mistakes, but that's that's a whole other talk that I only give in pubs. So the WSDL generator, I had originally thought was just a utility that was part of Visual Studio and part of an SDK. And then we were horrified to find that actually .NET itself has a WSDL parser in there. And that WSDL parser looks at the WSDL, it writes out a temporary C# file, it compiles that C# file, and then it loads it in process, which is a bit scary. But you know, it's WSDL, it's hard to hack WSDL until someone does it. And someone did a couple of years ago. Inside the parser that none of us knew existed, there is an isValid URL call. And this enabled, and this is where I get a little bit cagey, a nation state targeting Russian speakers in another Eastern European country that you border to compile code in their machine. And it was triggered via a Word document, because Word documents have this facility where they parse SOAP automatically with no user prompts, so you can bind to them as data sources. And it started off .NET, parsed the WSDL, loaded it up into Word, and then executed it, which then started sending things out from the Ukrainian users to a central server that was probably in Russia. So there's no real way to fix this other than don't annoy nation states with cyber warfare capabilities. So Russia, China, America, but most of the American exploits have leaked because they're just not good at keeping secrets. I would say the UK, but come Brexit, I think we have better worries. You really just shouldn't write code that generates code from user input, compiles it, and runs it in process. That is dumb and stupid, and we did it. And then someone forgot about it until it was exploited. But this is my first time of dealing with a nation state attack, and it was admittedly quite fun. And then we have mistrusting user input. And I am well on time. This was a new one in .NET Core, because when we started .NET Core, we looked at a bunch of the mistakes that the .NET framework made and threw them all away, and then introduced ones of our own that were new. And as part of MVC, there's a class called URL helper, and that generates URLs. And it generates absolute URLs so you can use them in weird things like emails and stuff. So it has the host. And the host, because we never wanted people to specify what the host was in config, which was silly, it takes it from the host header. And the host header is controlled by the browser or by the attacker or whatever is creating the HTTP request. So that doesn't sound too bad, because in a web environment, if you spoof the host header, you get incorrectly fully qualified URLs, and it doesn't matter, because if you click on them, you're just fooling yourself. But we use this function in password reset emails. And so an attacker could send a request to reset a password for a user, and it would look like it's come from the right mail server, because it has. It's been validated with your application's credentials. The email looks right, but the links in it go to a server controlled by an attacker. So an unaware user, of which there are many, probably in management, will just blindly click these things and fill in their usernames and passwords. Microsoft has like annual phishing tests, which is great, because I get to see my colleagues being more aware, and the way I get to see that is I get about 50 emails within an hour going, is this a phishing test? Because I've finally made them suitably paranoid, so it's also annoying. So the attacker can like fake a password reset email, and then we have users that click things, which is not their fault. It's ours, to be perfectly honest. And there was a bonus bug. Because Kestrel didn't actually validate host headers, he took this further, which was nice. And he embedded HTML in the host headers. The HTML got embedded in the emails, and there were certain email clients that would render the HTML and act upon it. So he had JavaScript that would submit forms when you read it in their email. I want to make this perfectly clear. This was not Outlook. Outlook used to have this sort of problem 10 years ago. It was, in fact, another web-based client from another large corporation. So you fix this, and this is actually a general thing. It's very easy to bind your service to just listen on an IP address and for any sort of host header, but you need to constrain your input to everything that you know is valid. You need to only listen to host names that are yours. It's a bit of a pain when you're deploying because now you have to figure that host header out beforehand and make sure that your web server configuration is limited to it, but it's the right way to do it. Oh, and also read the HTTP spec and validate it and don't allow script tags. That one's on us. So finally, I'm going to talk about padding oracles again. This one's a little bit more complicated. It's not a bug, it's an advisory, and it's an advisory that we sent out industry-wide. And we talked to Sun about it, and we talked to Google about it, and we're hopeful that people would actually write advisories and instructions on how to do this sort of thing correctly, and some languages have, and some languages haven't. You remember I said you could detect things via exceptions and timings. You can't really turn exceptions off in a language. And, excuse me, it's so hot. Exceptions are a language feature, and if you have a language that throws exceptions, you have a padding oracle, and it didn't used to matter. The time taken to build an exception was not really detectable across the internet, but as we have got faster and faster internet, and as we have moved things to the cloud, where an attacker could put a service next to yours in a data center, these things have become more and more detectable. And so now you can detect the gap, the extra time taken to throw an exception, even if that exception is not exposed to the attacker or to the user. So when you are encrypting your data, it's no longer enough to encrypt it, even if it's not round-tripped. You need to add this authenticated signature to your data and validate it before you do any cryptographic operations. Again, it's the same sort of thing we had with ViewState and the same sort of thing that we want to underscore. And this isn't just a .NET thing, it's Java, it's Ruby, it's pretty much every single language that has exceptions. And encryption is hard. And trying to get the right information out and the information updated everywhere is even harder. So what I really want you to take away from all of this, apart from the fact that I make too much fun of SharePoint, is that you shouldn't be using unconstrained binary formatters. You should be using serializers which allow you to say, I only expect an object of this type. You should be signing your data, even when it's encrypted, and sign it with an authenticated mechanism. Sign it with an HMAC. Limit the array sizes that you build from user input. Don't allow unconstrained array sizes. gRPC is great for this. I mean, it's new, it's fancy, and if you look in the gRPC spec, it says, by the way, this command will tell your receiving application to allocate this much memory for what comes after. And a lot of gRPC libraries have not put restrictions on how much memory they are going to allocate, which is a bit of a problem. Don't use regular expressions because you're horrible. Or if you must use them, make sure that you have a timeout on it, and always validate your inputs. That was a very quick run through things that have given me ulcers and upset my honeymoon. And I have a couple of minutes for questions. Wow, does anybody have anything? I know sometimes you don't want to ask security questions. I will accept security questions over email and do my best to answer them, although obviously I can only talk to .NET solutions. You're all being quite Scandinavian and Swedish and not answering anything. No questions at all? Okay. Well, the recordings, I have recordings of previous versions of this. The slides will be up in about 50 minutes. I hope it's been useful to you. All of those takeaways, go look at your encryption. Go look at your input validation. Go look at your serializers. Some of them are available. There are older ones available on GitHub. I've kind of given up trying to keep them up to date, but the regular expressions. You don't get the binary serializer exploit. No. Nice try. So you can't take down your company's SharePoint. That would just upset too many people at work. But there are links to papers, and there are links to the researchers, and you can figure it out from there if you want to be a really naughty person. But I would advise not doing that. The simpler exploits are available up on GitHub, and there's links to that on my website. You want to take down SharePoint. I'm not helping you take down SharePoint. No, you're a bad person. Thank you very much for coming. Have a great rest of your day.